Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Deep beneath your feet, a silent recorder has been documenting the pulse of our planet for billions of years. We often think of history as something written in books or etched into monuments, but the most profound chronicle of Earth's existence is written in the language of magnetism. This is the story of the Hematite Archive, a geological ledger made of iron and oxygen that reveals the shocking truth about our planet's shifting shield. To understand this archive, we first have to look at the mineral itself. Hematite, a form of iron oxide, is often nicknamed the bloodstone. When you scratch a piece of hematite, it leaves a distinctive, rust-red streak that looks hauntingly like dried blood. But its importance goes far beyond its appearance. Hematite is one of the most stable magnetic minerals on Earth. Its atomic structure allows it to act like a microscopic compass needle. When hematite forms, whether it's precipitating out of ancient oceans or cooling from searing volcanic magma, these tiny needles align themselves with the Earth's magnetic field. Once the mineral solidifies or settles, that orientation is locked in place forever, creating a permanent record of where north and south were at that exact moment in time. For decades, geologists were puzzled by the patterns they found in the Earth's crust. In the mid-20th century, as we began to map the ocean floor, we discovered something extraordinary: stripes of alternating magnetic polarity. In some sections of the rock, the magnetic north pointed exactly where it does today. But in neighboring sections, the polarity was completely reversed. This was the first clear evidence of geomagnetic reversals, events where the Earth's magnetic field literally flips upside down. The Hematite Archive provides the high-resolution data needed to understand these flips. Because hematite is so resistant to chemical weathering and heat, it can preserve magnetic signatures for billions of years. Some of the most important entries in this archive are found in banded iron formations, or BIFs. These are massive, striped deposits of iron-rich rock that formed billions of years ago when the Earth's atmosphere was first being flooded with oxygen. As iron dissolved in the oceans reacted with this new oxygen, it rained down to the seafloor as hematite and magnetite. This rain created a layer-by-layer recording of the Earth's magnetic state during the Archean and Proterozoic eons. But why does the Earth's magnetic field flip in the first place? To answer that, we have to travel 3,000 kilometers down to the outer core. Here, a swirling sea of liquid iron and nickel creates a giant electromagnetic dynamo. This movement is driven by the planet's rotation and the escape of heat from the inner core. It's a chaotic, turbulent system. Occasionally, the flow of molten metal becomes disrupted. The main magnetic field begins to weaken, and smaller, chaotic magnetic poles begin to pop up all over the globe. Eventually, the field stabilizes again, but often with the poles in the opposite positions. The Hematite Archive tells us that these reversals aren't just rare anomalies, they are a regular feature of our planet's life. On average, a flip occurs every 200,000 to 300,000 years. However, we are currently overdue, as the last major reversal, the Brunhes-Matayama reversal, happened about 780,000 years ago. By studying the intensity and direction of the magnetism trapped in hematite crystals, scientists can see the warning signs of a flip. They've noted that the magnetic field has weakened by about 10% over the last 2 centuries, leading some to speculate that we might be entering the early stages of a new reversal. What would a magnetic flip mean for us today? During a reversal, the magnetic shield that protects us from solar radiation and cosmic rays becomes much weaker and more complex. While it wouldn't be an extinction event, life has survived hundreds of these flips before. It would pose a massive challenge for our technological civilization. Our satellites, power grids, and navigation systems all rely on a stable magnetic field. By decoding the Hematite Archive, we aren't just looking at the past. We are preparing for a future where our compasses might one day point south to find the Arctic. The beauty of hematite is that it turns the abstract concept of planetary physics into something tangible. We can hold a piece of 3 billion-year-old rock and know exactly how the Earth's core was churning when that rock was born. It is a testament to the interconnectedness of our world, how a microscopic crystal of fossilized blood can hold the keys to understanding the giant, invisible forces that keep our planet habitable. As we continue to refine our techniques for reading this archive, we uncover a more detailed map of Earth's turbulent history, one iron atom at a time. For more incredible facts like this, don't forget to subscribe and turn on notifications.